Minasan, konnichiwa. Nice to meet you. My name is Marco, and I'm here today to talk about HTML-aware ERB tooling. If you haven't met, I would love to say hi after the talk and meet you. I have been doing a lot of open source the last few years, and you can say I love open source. I've been doing a lot of open source things. And most prominently, I was part of the core team for Stimulus Reflex and Cable Ready, and I've been maintaining Stimulus over the last few years as well. Most of my open source contributions were in the Hotwire ecosystem, and mostly around Hotwire, Stimulus, Turbo, and all of that. And over the years, I started to get more interested into improving the developer tooling in the Rails and Hotwire ecosystem. That's why I'm here today to talk about Hotwire and HTML ERB tooling. And something has been really kind of holding us back a little bit, so that's why I think I want to address some of the things here today of how we can improve the way we work in our HTML ERB views and apps. But first, I want to talk a little bit about the history of Ruby developer tooling. It's true that for most of the time that Ruby existed, there was no really tools, a lot of tools around for the editor, especially in the way we know it today. Most editors just had basic support for Ruby, so there wasn't really anything fancy like LSP and autocomplete. It's just the way you were used to and how it wasn't back in the day. This kind of changed in 2008 when RubyMiner was announced for the first time, where we got some more advanced features on autocomplete and indexing and just the way you can write and work with Ruby. So it was typical back then that every editor that was introducing Ruby support had to write some integration to make Ruby work in their editor. And that's been mostly the situation for almost a decade, up until 2016, when Microsoft introduced the language server protocol. The idea of the language server protocol is that you can write one implementation of a so-called language server for one language, and each of the editors that support the language server protocol can use this too, and then have all these features built in as well. And a year later, we got the first language server for Ruby, which was called Solograph. And at this time was when more and more of these LSPs showed up over the scene, and we got tools like the Python LSP, the TypeScript LSP, and the Tailwind LSP. And so there was more and more of these tools. For Ruby, Solograph showed that this was possible to also do it in Ruby, even though it's such a dynamic and flexible language. But then later in 2022, we got the Shopify Ruby LSP, which really improved the way language servers work for Ruby, the way it was done. One thing I noticed from working in the wider JavaScript ecosystem was that the JavaScript tooling was really awesome, and the developer experience in these tools was really great too. So my idea was to bring over these tools that we know and love from the JavaScript languages over to the Ruby and Rails ecosystem, which is why I ported over a Stimulus language server that worked with the HTML in our Rails applications. So what this did was it was analyzing the Ruby files and the HTML ERB files to look for instances where you were using Stimulus. It helped you autocomplete with the attributes, and it helped you guide some with diagnostics that some things might be wrong. So it was looking at your JavaScript files to see if you set up the things the right way with the naming and the conventions how Stimulus uses it. And then a year later, we got the Turbo LSP, which did the similar thing for Turbo. But the thing here was it was a super limited, super basic language server implementation. But at this point, it was clear to me that LSPs are the future of dev tooling. But as I was mentioning, there was something missing to really make this the right thing. So Stimulus and Turbo LSP were HTML only, so they only worked on HTML syntax. Now, this would have worked in this file here too, which could have been an HTML ERB file. But it only worked for the HTML static syntax. If there were any ERB tags in here, it would just ignore them. So Stimulus LSP was looking at these attributes, giving you guidance, autocomplete, and diagnostics to make sure you write the right code. But as I mentioned, no ERB support. But for most Rails apps, it's quite common that you use active view ERB helpers. So you might see uses like that where you use tag.diff or where you use a hash syntax for the data attributes. But this meant that we get no errors, no diagnostics, no recommendations for these ERB snippets. So we have to understand the ERB. And the fact is that there was not really any ERB tooling, especially no HTML ERB tooling in the ecosystem. So why do we want HTML ERB tooling? I think now it matters even more than ever because as of Rails 7, Hotwire, Stimulus, and Turbo are the default set for the frameworks for the front ends that have been established. It also shows in the Rails developer survey from last year that Stimulus rise from the almost second to last place to the first place last year and has now a 31% share over the whole participants of the survey. In the JavaScript state of the JS survey, we also saw something similar with Alpine.js, which is quite similar to Stimulus, that there has been some gain in popularity. This is not a lot compared to the rest of them, but the JavaScript ecosystem is much bigger, so it's kind of interesting to see that there's still an uptick in this development. Similarly, with HTMX, which is similar to Turbo, there has been some advancements there too and some popularity gains as well. So I think the advanced HTML tooling is getting more important now. So my idea was to add ERB support to all the tools we have in the Ruby ecosystem so they work with these developer tools as well. So at my Rails World talk 2 years ago, I was introducing the Stimulus LSP, and I had this slide up where I also showed that I have plans to add this ERB support to the Ruby LSP or the Turbo LSP as soon as this works out. And then a few months later at the RubyConf Hack Day in Chicago, we had the goal to just see what it takes to make this work in Ruby LSP. So we got together to work on this, and we quickly realized that there is more that we need, or that we need more advanced tooling than what we could do at the moment. So it was more than we needed, and we needed more than the basics we had at the time. The thing is that ERB is versatile, so you don't have to use it with HTML. You can use it for emails, you can use it for YAML files, you can use it for texts. It doesn't really matter. But the thing we care about is that we want to use it with HTML. So we want to look at HTML and ERB at the same time. So we have this plan to add support for this. So can we just use Nokogiri and Prism to make this work? So if you have a look at this file here, this is a standard ERB and HTML file. What we could do is we could split this up and look at this from 2 different angles, one from the Ruby aspect and one from the HTML aspect. Then we could say, let's remove the Ruby from the HTML and the HTML from the Ruby, so we just have the source of each of the languages left. Now, we could use this. We could use Prism to parse the Ruby parts. We could use Nokogiri to parse the HTML parts. And this would work, and we get the result back. But the problem is that we lose the context of where we have been interpolating the ERB inside the file itself. Another problem is that the output from the Nokogiri here doesn't include any location information. So it would be super hard to bring these 2 results back into one syntax tree that we can use to analyze the Ruby ERB file. So we lost the context, and we needed some way to piece this together again. But even if we would be able to do this, we wouldn't have any control over the edge cases of what we would be doing if there's invalid syntax, if there is anything we didn't expect. It's really hard to then piece this together again. So if you take a look at these examples here, in the first example, it doesn't really matter where we're interpolating because it's just at the top level. But if you look at the attributes, it really matters where we are interpolating because this could lead to a cross-site scripting attack if you control the attributes value. Or if you just are interpolating in an attribute value, it's different again. So we want to know where we want to interpolate to be able to build the tools around it. So I knew I wanted to build this thing, and so I knew I had to build my own parser to be able to do that. And this is the idea of where this HTML-aware ERB parser came from. I was looking around if there's anything like this already in the ecosystem, and I found a few of these parsers that were HTML-aware, but none of them really went that far that I was thinking or hoping for to build these tools I had in mind. So I did some early experiments and was trying to figure out in which language I want to write this in. The Stimulus and TurboLSP are written in TypeScript, and the RubyLSP is written in Ruby. RubyKaigi is written in Ruby, so we would have to use one or the other language. But since we want not to use JavaScript from Ruby or Ruby from JavaScript, I was thinking there must be something else. So I was thinking maybe it is the best to follow Prism's lead and implement this in C. The thing is, I didn't know C, so I had to figure out C first, but eventually I got it to work. And that's what I'm here today to show you. I have written a parser. It's called HERB. HERB stands for HTML and ERB. That's the name. And I want to show you what it can do today. So what is HERB? HERB is a set of tools that is designed to make it more productive to work in HTML and ERB files. As of right now, it consists of 3 pieces: a parser, a formatter, and a linter. And we're going to take a look at the parser first. So this is a handwritten parser that's HTML-aware and can parse ERB files. It's written in pure C99 and has no additional dependencies, which is following the lead of Prism again. The only dependency it has is Prism itself for parsing the Ruby snippets in the ERB file. And also here, it's trying to follow Prism's design goals of being portable, error-tolerant, and maintainable. And here, especially the portable aspect was important to me because I wanted to use this from JavaScript, I want to use this from Ruby itself, but maybe leave it open to other languages as well if you want to write more bindings. So this also features now a custom HTML extern parser, which is not one that I could just use from anywhere, because an HTML-compliant parser would try to fix some of the missing tags, would try to shift around some of the nodes in the tree. But what we need and what we want is that we want to represent exactly what's in the file in the parse result. So this parser is designed for tooling, not the same way as browser would run in the interpreted HTML. And what it exposes in the end is a clean syntax tree of the interleaved HTML ERB in one result. So this is, as I mentioned, written in C. It has bindings for Ruby. It has JavaScript and TypeScript types as well. And all you have to do today is to add gem herb to your gem file or whatever. And then you get to use the herb interface, the Ruby API, to parse, extract Ruby code, extract HTML code from any ERB source. We also provide 2 packages for Node.js and the browser. The browser package is using a mscripten WebAssembly build, so you can run this fully in the browser without any server requests. And it also has the same API for both of them, so you can use the JavaScript API to parse and work with ERB files. So let's take a look at how this works. So for an empty document, if there's nothing in your document, all you get back is a document note. You have some location information, you have errors, and you have the children of the document. So let's add some text content and see how this looks like. So now we have this text in our documents, and you can see there's an HTML text node now in our children array, and it represents this text as you would expect. Now, if you are writing out a document in your editor, you never have a full complete document as you are writing it. As you are typing it out, there might be syntax error, there might be an incomplete document, so we want to handle that in a way. So this is why we have support for partial HTML elements as well. And what you can see here is that if we open the H1 tag and we don't close it, it has an error in the errors array, as you would expect. And then you can see here that there's an HTML element node to represent this H1 tag. It has an open tag because that's what we see in the document, but the close tag itself is null to represent that there is a missing close tag. If we would use the same document with Nokogiri and would parse this with the HTML5 fragment and convert it back to HTML, it would return you the full element, including the closing tag. But as you can see, this closing tag was never part of our initial inputs. So if you want to build tools around this, it's not really helpful if we get additional nodes injected into the parse result. And that's why mostly I was thinking it makes more sense to write our own custom Lexron parser. This obviously works for complete HTML elements too. So if you give it a complete HTML element, it has the element node, an open tag, the content text node, and then the close tag at the end. This works for nested elements too. So you have element nodes inside the element node, and at the very bottom you have the text node inside of it. Now this is all HTML at this point, so we want to take a look at ERB as well. So if you just have an ERB output tag like we have here, it will represent this as an ERB content node, including the tag openings, the content, and the tag closing as separate tokens on the result. You can also see that it's parsing this already and that it's valid Ruby as a whole. If we see that this is valid Ruby, we don't touch it anymore. But if we see this is incomplete Ruby, like for example, if we are dealing with control flow structures, we are doing a second processing step here. So if you look at this document here, you have the if opening ERB tag and the end closing tag. And the way this parser sees it, the first pass through, is that we have three elements: a ERB content tag, the two new lines to indicate the two new lines, and then the closing end tag. So what we do now is we traverse all the ERB content nodes and parse them with Prism and do some analysis to figure out if they need to be put together to form a bigger construct. So in this case, we have this if nodes, and what we do here is we see the if nodes, we collect all the nodes up until we see the second end node and put all of these elements inside of this ERB tag, or this if tag. So in this case, we transform this from the three of them to one of them, and this is going to be an ERB if node, and inside of it, it has the two new lines as before. But the end tag is now a property of this whole construct, which is the if node. So this gives us one object to deal with, and we know the nested nature of these elements now. This gets more interesting if we start to nest HTML tags in it too. So if you put the h1 tag in here, we can now see, it's a little bit small, but you can see here, we have the opening tag again, the closing tag at the bottom, and these two form the if tag, or the if construct. And inside of it, we have this h1 element, which is now nested in this if construct. So this gives us some hierarchy and opens us some doors to be able to understand more about the nature of this HTML ERB document. We can also more precisely analyze it, and then also maybe transform or rewrite some of the stuff because we know exactly what's in the document itself. It also supports attributes, doc types, comments. It also includes all the white space, so this might be important too. And for the control flow structures in Ruby, we support all of these constructs here, and each of them have a separate representation in the ERB node too. So there's a second ERB if node, there's an ERB case node, there's an ERB begin node, and so on. All of them follow the exact same design as the Prism nodes. So if you would want to convert one from the other, you could do this very easily. And this is what's available today. This is the first public release I want to share today. This is now open source under my GitHub handle under /herb. And at least for me, this is now where the fun can begin. We have the foundation to parse and understand these ERB documents, and now we can build more advanced tools on top of it. So if this sounds interesting to you, I invite you to take a look at this and see if you have any ideas to build with this. And maybe we can improve the ERB tooling together. If you just want to try and see what this is like and what it feels like, we have an interactive browser-based parser playground as well. So this allows you, on the left side, you have the content of the document. On the right side, you have the parse results. And as you scroll through, click on the nodes, you can highlight the source location of these. And this works in both ways, so you can click and forth on both sides. This is super helpful to just see what the process is and helps with debugging some of these documents that are more complex. So this is under herb tools, dev/playground, and feel free to check it out. Now, to look ahead, we have been talking about the parser now, but there are two more pieces here. So this is the formatter now. The idea here is that we want to build the HTML ERB auto-formatter, as you might know it from Prettier or from RubyKaigi, some of the rules there. The idea is that you give it some unstructured ERB document or some slightly unstructured ERB document, and including in the LSP or in some CLI, when you hit Command Save or run the herb format command, it will output this formatted document for you. I'm thinking that there might be some configuration rules of how you want to structure these ERB nodes, but the idea is that this will just format it for you. There have been some tools that did this in the past, but they always required you to have Ruby installed, to have the gem in the right path and the right location for it to figure it out. But I'm hoping that this will just work out of the box when you install the LSP, that this just works because it's not dependent on Ruby itself anymore to work. And then lastly, the linter. As I mentioned earlier, we want to build a linter, but the thing is that we don't have a fully compliant HTML parser, which is by design. But what we can do, because we see all the stuff in the syntax tree, we can check for validity with HTML5 after the fact. So we can check, do you have the right elements in the structure? Do you have invalid tags nested under each other? Are we missing some alt attributes on image tags, or are we doing unsafe interpolation somewhere in the document? This is just like some examples of what we can build and build rules for. And maybe this can also just tightly integrate with RubyKaigi, so you can run this as part of your regular RubyKaigi run. And one more thing about this, which I was working on, this whole idea of just writing this parser, I noticed that there's some, I guess, possibility to also build a new, smarter ERB rendering engine. And this is kind of the vision that I want to share at RailsConf later this year. And this is codenamed Reaction View. So the idea here is that we built an Action View add-on that will understand these ERB views and can analyze how the ERB views are structured, and then more smartly update and re-renders part of the template when its state changes. So we'll show an example here. So we have a basic template, which is the items array, and we loop over it. We render out a list item for each of the items. The instance variable here is kind of representing the state. So we have 3 items in the state, and then in the bottom left, you see the rendered view itself. So we render this initially, send it down to the client from the server, and then in some way, the state gets updated. We have a 4th element in the state now. So we want to reflect that. We see that the state changed, that the items changed. So we want to re-render the view. So we look, did the items instance variable actually contain in the view? And we see it is here. So we see that, and then we see, okay, we just have one more item new. So we just re-render this part of the template, and then render the diff for this 4th element. And when we do that, we just get this 4th item, and all we have to do is then to apply this to the results and then reflect this state change. This is super similar to how Phoenix Live View in Elixir handles this, and that's where the main inspiration from this comes from. One more thing that I have here to discuss is other thing I have been noticing, that maybe there is possibility to write a HTML templating syntax tree. What this means is that we have been focusing on ERB and HTML for now, but we have a few other templating engines like Haml and Slim. And if we do this the right way, I think there's a way that we can bundle these efforts and improve the tooling in general for all of these tools together. So this includes all of these template languages as well. And the way it works now, this is how Herb does it today. So you have this HTML ERB view. This gives you a parse result. And the same is true for when you're using Action View. with these helpers that gives you the same result as well. But we could also do this with HAML. So whenever we see this HAML syntax, we translate this into the same parse results and could do the same thing for Slim. And if we do this, we can build all the tools for HTML itself on this parse result that we share between these engines. So the rule is, as long as we can transform the syntax into the same tree structure, we can reuse these tools for all these source files. And that means we can combine the efforts to build more advanced tools on top of HTML templating. OK, so what's next for the short-term future of Herb? So we want to ship these two features, the format and the lintern, very soon. They are currently in progress. I couldn't finish them in time for this presentation, but they are on the way. And then the other thing is that we want to integrate this parser now into the existing ecosystem of tools. So this means we want to add it to Stimulus LSP. Maybe we can write a Ruby LSP add-on to integrate it into Ruby LSP directly for handling the ERB files there too. And also more advanced tools for Turbo LSP, so we can look at all the turbo frames and turbo streams, the helpers to make it more easy to work with. So you want to add more diagnostics, more code actions, refactoring tools, transformations, and all that stuff. Then we are still missing the view helpers, the action view helper support. They are on the way too. So this just means that we want to see or transform these syntaxes here for using link tags, content tag, if we use the attributes for the data attributes, the hash syntax. We want just to transform this syntax into the same HTML representation so we can build tools on top of it. So when you are building tools for HTML, it doesn't matter if it's actually HTML itself or if you are using these helpers here. Another thing that's quite interesting is that we can do multi-file analysis and diagnostics. Because we understand all these views now, we can see, OK, you're rendering a partial here, and we can look up where this partial might be, and then kind of construct a whole tree of all your view files and partials, and then build or give you some maybe unused view file found here, so you can refactor these out if you don't use them anymore. So this parcel is now ready, and I found when I was working on this that there are a few gems out there that do something very similar, but aren't quite there yet. So maybe this parser can help refine some of these gems to make them more easy and maintainable. So to conclude, Prism itself has been really awesome to work with. I have been using this heavily for this project here, obviously. But Prism itself is now shipping with Ruby 3.4 as of last Christmas, and I think it has had a big impact on the whole tooling ecosystem and the Ruby internals itself. And I believe that Herb itself could have a similar impact in the way HTML template tooling works, but also that it could power this more advanced ERB rendering engine that could be used for smarter updates in the front end. And I think it's fair to say that the community itself has built really awesome tooling around the Ruby ecosystem over the last few years. And I think that now it's time to build the same level of tools and the same care, same level of detail for the view layer as well. And I think that with Herb, we have a path forward to make this happen. In the end, I love Ruby, and that's why I'm here today too. I want to keep writing Ruby. I want to keep Ruby as attractive as possible for people to get started and use as well. So this has been my presentation about Hotwire and HTML ERB tooling. And I've prepared a slide here for a summary of what we talked about today, including the Ruby gems, including the NPM packages, the Herb tools, and these more advanced tools for HTML and ERB. And then finally, I want to thank all of these people that have, in some way or form, helped out with this release today that made it happen. Some of them helped out with testing. Some of them helped out with contributing codes. Some of them have helped out with the gem name. Others have helped out with design and branding. But all of them have been here to help out to make this release possible. And then finally, a big thanks to all the contributors for Prism, Recompile doc, and then Mike's Ruby C Extension Explains repository, which helped me bring herb to Ruby in a native extension. So this is herb tools. This is the parser for HTML ERB. And if you have any ideas, opinions, or questions, feel free to reach out after the talk. And that's all I have for today. Thank you so much.